Hi, welcome back. This is Professor Ridge and today's lesson on section 8.8, problem solving in quadratic functions. So basically we're just doing word problems with quadratic equations. So let's try number 10. Okay, so recall that total profit P is the difference, this keyword there, difference, between total revenue and total cost. Given that R of X, that's your revenue function, is 1000X minus X squared, and your cost, C of X, is 3000 plus 20X. Find the total profit, the maximum value of the total profit, and the value of X at which it occurs. So we want to get a total profit function. So they pretty much told us profit is equal to revenue minus cost. So let's plug in their numbers. Revenue is 1000x minus x squared. Cost is 3000 plus 20x. So don't forget to distribute that minus sign. So that'd be minus 3000 minus 20x. Combine like terms. So we get, let's put it in descending order too, minus x squared plus 980x minus 3000. That's our profit. Okay, so that was part A. B, we want the max value. Max value. So remember, the max value. This is a parabola that opens down. If you think so, the maximum value is going to be the y value of the vertex. So we need to figure out what the vertex is. That's going to be h is going to be equal to minus b over 2a, which in this case will be negative 980 over 2 times negative 1, which is what, 490? So it's negative 980 divided by negative 2, which is 490. And K is going to be equal to F of 490. Well, in this case it would be P of 490. Now remember, for B, the maximum value is going to be the y value, the k value of the vertex. So 490, so I get out my calculator. Let me get my calculator. Okay, so plugging in my calculator, negative 4, okay, I got to do 490 squared, then the minus sign, plus 980 times 490 minus 3000, I get 237,100. Now remember, the max value is of profit, so the maximum profit is going to be this number, K, 237,100, and it happens at, or occurs at, or occurs when X equals, what was the X value? 490 units, whatever X is. Okay? So again, the max value is the Y value, and it happens or occurs when you get the X value of the vertex. So let's try number 14. Ginger is fencing in a rectangular garden, uses the side of her house as one side of the rectangle. What is the maximum area that she can enclose with 40 feet of fencing? So let's say this is her house right here, and we want to enclose an area, a rectangular area for gardening. We'll call this X, Y, X. So we got area we know of a rectangle is length times width, which in this case would be x times y. And we know that we got 40 feet of fencing. 40 feet of fencing. And the fence is going to be the sides that I got to put up. I'm going to have the x plus y plus x is going to be 40. So that's 2x plus y equals 40. Now, to maximize the area, this is what we're going to maximize. And write as a function of just x. So we're going to solve this one for y. We're going to solve the restriction of fencing. So solve for y. So we're going to subtract 2x. So y equals 40 minus 2x. And plug it into the area function. So we're going to get area function. We're going to write area as a function of x. It's going to be x times y, which is 40 minus 2x for my restriction of my fencing. So now you see that area is 40x minus 2x squared is a parabola that opens downward. Let's write it the right way. Minus 2x squared plus 40x. So it's opening down. So we're going to get a maximum value at the vertex for area. So again, what I do is h is going to be opposite of b over 2a, which is negative 40 over 2 times negative 2. Negative 40 over negative 4. That's 10. So that's going to be my x coordinate of the vertex. So let's see, what are we looking for? What is the maximum area she can enclose? So that's going to be my k. So I'm just going to put in k, which is a of 10, which is 40 times 10 minus 2 times 10 squared. Punch that in my calculator. 400 minus 200, that's 200 square feet. This is my maximum area. Okay, so let's try number 18. It says, what is the maximum product of the two numbers that add to 26? What numbers yield this product? Okay, so this is pretty similar to the last one we did, really. So if we let x equal the first number and y equal the second number, two numbers that add to 26, so x plus y equals 26, and we want to maximize the product of these two numbers. So if we do product of the two numbers, that's x times y. And again, the idea is you want to maximize this, so you want to write it as a function of x. So write as a function of x. So that means we got to use the restrictions here. Solve this one for y. So let's see. We're going to subtract x from both sides. So y equals 26 minus x, and plug it into the product function. So the product of x as a function of x is going to be x, take the y out, put 26 minus x. So it's 26x minus x squared. So pretty similar to the one we just did. So again, maximum product, this is a parabola that opens down, so we're going to get a maximum at the vertex. So the vertex h is going to be equal to minus b over 2a, which is negative 26 over 2 times negative 1, which is 13. And k is going to be p of 13, which is negative 13 squared plus 26. So again, you got to do the square first, then take the negative. So that's going to get us 169 plus, hang on here, 26 times 13 is 338. And that's going to get us 169. Alright, so let's see. Let's answer the questions. Find the maximum product. So again, that's going to be the k value. So maximum product is going to be equal to 169. That's part 1. And then what numbers yield this product? Well, let's see. If x is 13, y, so if x equals 13, y is 26 minus 13, so it'll be 13 and 13. Okay. Alright, so that concludes the lesson for 8.8. Go to My Math Lab, complete your exercise there, and I'll see you next time.